Somewhere out there in the solar system, orbiting the Sun every 271 days, is an asteroid called 2023 DW that was recently spotted when it came within just 9 million kilometers of Earth. It's a 50-meter diameter rock, about the same size of rock that caused the Tunguska Event. NASA said 2023 DW had a 1 in 560 odds of hitting the Earth in 2046, giving us a pretty good chance the rock will miss the Earth entirely. But what would happen if something changed its orbit and it was suddenly on a collision course with Earth? What level of devastation would result from such an asteroid impact if it happened over a city and not in the frozen wasteland of Siberia? Could we deflect or push this asteroid away from Earth before it hits us? Discovered in February this year, the 2023 DW asteroid is currently racing through space at approximately 86,400 kilometers per hour. The odds of the asteroid striking Earth on Valentine's Day 2046, as estimated by scientists, are 1 in 560. But some researchers have put forward different calculations, one of them being a 1 in 400 chance. There's even an estimated area where the space rock might land marked by the red dots in this image. The potential impact sites extend from a location near the southern tip of India to an area near the eastern coast of the United States. When evaluating the risks posed by near-Earth objects, scientists employ various metrics, including the Torino scale. Typically, potential threats register a score of 0 or below, indicating minimal concern. However, in the case of 2023 DW, NASA assigned it a score of 1 on the 1 to 10 scale, signifying a somewhat elevated level of risk. Over the course of its orbit around the Sun, 2023 DW is expected to make 10 close passes by our planet, with the first one projected to occur on February 14, 2046. The asteroid's closest approach during this period will take place on that same day at a distance of about 0.009614 astronomical units away from Earth. As astronomers continued the risk assessment, the probability of the asteroid colliding with our planet decreased to 1 in 1,584. But what if something goes wrong and scientists' calculations are incorrect? How devastating would the impact be? According to a scientist at NASA's Center for Near-Earth Object Studies, you could compare it to the Tunguska Event, which involved an asteroid of similar size exploding in the atmosphere above a sparsely populated region of Siberia in 1908. The power of an airburst caused by a 50-meter wide asteroid, equivalent to a 12-megaton nuclear bomb, could result in a similar catastrophe. If the asteroid 2023 DW were to smash into Earth in the wrong location, it could result in a catastrophic event that would destroy a city. The Tunguska Event explosion covered an area approximately 2,000 square kilometers. More than 80 million trees were flattened, and a huge number of trees and bushes were burnt to cinders in the explosion area. Eyewitnesses described seeing a fireball as bright as the sun. Seismic and pressure waves were recorded in many observatories throughout the world, and bright lights in the sky at night were observed over much of Eurasia. Just imagine this kind of explosion over a populated city. So what can we do in case of a genuine threat? NASA and the European Space Agency have been actively exploring ways to deflect potentially hazardous asteroids. In a recent test, NASA's Double Asteroid Redirection Test spacecraft demonstrated that it could alter the orbit of an asteroid by deliberately colliding with it. Following this successful test, the ESA is planning a similar mission called HERA. ESA's HERA spacecraft is set to launch in October 2024 and is tasked with performing a detailed survey of the binary asteroid system known as Didymos, specifically its moonlet Dimorphos, which was impacted by NASA's DART mission. HERA will be equipped with advanced technology, including automated guidance and control, to navigate the asteroid system safely and survey the crater left by DART. It will also measure Dimorphos's mass and composition using a set of instruments including an asteroid framing camera, thermal and spectral images, and a laser altimeter for surface mapping. HERA will also deploy a pair of shoebox-sized CubeSats to the vicinity of Dimorphos. As the first spacecraft to rendezvous with the binary asteroid system, Hera is Europe's flagship planetary defender that could be used in future asteroid deflection missions. By the time 2023 DW makes its closest approach to Earth in 2046, space agencies and policymakers will have a better understanding of how to deal with a potential impact threat. The success of the DART mission provides hope that if necessary, the orbit of a threatening asteroid could be altered to avoid a collision with our planet. None of these plans, however, will be put into priority unless the odds of an impact go higher than 1 in 100. But what if we face an asteroid that's immune to our strikes? Recent research on the Itakawa Asteroid suggests that some asteroids may be far tougher than previously assumed. Scientists believe that it may have formed over 4.2 billion years ago from the shattered remains of a monolithic asteroid. Porous rubble pile asteroids, or half-empty collections of loose boulders, are surprisingly durable. Examining the dust particles from Itakawa, scientists have found that the asteroid has survived catastrophic collisions for almost the entire history of the solar system. And this is a big problem for current deflection strategies aimed at transferring the momentum of kinetic impacts as porosity decreases the efficiency of such impacts. However, the study also suggests there may be more aggressive approaches. One of them is nuclear blast deflection, which would have a much higher chance of success against these porous asteroids. We might need to develop new mitigation strategies to prevent asteroid collisions with Earth, because who knows how many more surprising qualities space rocks may still hide. The ongoing exploration of asteroids by missions like Hayabusa and OSIRIS-REx is expanding our knowledge of these cosmic rocks and their potential impact threat. Starting in 2024, the Vera Rubin Observatory will conduct a broad survey of the sky. Scientists expect to detect thousands of asteroids that could pose a threat to Earth. Meanwhile, NASA's NEO Surveyor mission, set to launch in 2028, will significantly increase the number of known asteroids. Scientists are also developing a new way to track asteroids more accurately using a cloud-based data analysis technique. This will help distinguish between near misses and real threats, making it easier to prevent future asteroid impacts. As technology advances and we continue to explore the cosmos, we're constantly discovering new asteroids that could potentially pose a threat to our planet. In the coming years, there could be even more hazardous objects lurking out there, waiting to be discovered. There are millions of asteroids floating in our solar system. Every year, thousands of meteorites weighing about a pound fall on Earth. Usually we don't see them because they land in uninhabited forests or the ocean. However, in 2004, scientists discovered a really dangerous asteroid in space, weighing more than 20 million tons. The first observations show it has a 2.7 chance of hitting us in 2029. If an asteroid this big hit the Earth, it would cause major devastation over the area it impacted. But what is the real chance of it hitting us? And what can we do to prevent big asteroids from hitting our planet in the future? Apophis was first discovered on June 19, 2004 by astronomers in Tucson, Arizona. The asteroid measures about 1,100 feet across, about the size of 3.5 American football fields. It raised alarms because initial calculations had shown there was a good possibility it could smack into the Earth April 13, 2029. Since its discovery, optical and radar telescopes have been tracking Apophis as it orbits the Sun, and scientists are mostly confident they know where it's headed. Current calculations show it will come really close to the Earth at around 19,800 miles from our planet's surface in 2029. That's close enough to come between the Earth and the Moon, which floats around us at about 238,855 miles away. The path the big asteroid is taking is within the distance of some satellites, and that sounds too close. But what if something affected the orbit path of Apophis, which is very possible, and this asteroid smashed into our planet? It's a well-known fact that an asteroid impact is one of the things that can cause global mass extinction, especially if this asteroid is large enough. Physicists like the late great Dr. Stephen Hawking said that an asteroid collision is the biggest threat to all life on the planet. If an asteroid like Apophis was to hit the Earth, the impact would unleash a blast equivalent to over 1 billion tons of TNT. In comparison, the recent explosion in Lebanon, Beirut, of approximately 2,750 tons of ammonium nitrate caused an explosion equivalent to 1 kiloton of TNT and took the lives of over 200 people. Thus, an asteroid impact by Apophis directly over a populated area would not only result in the deaths of millions of people, but would also have a terrifying and lasting impact on the ecosystem of our planet. Although it may not be an extinction-level event, it would forever change our biosphere and affect human civilization for centuries to come. Asteroids were crucial in the formation of planets in our solar system. Major impact events have significantly shaped our Earth's history and have been associated with the formation of the Earth-Moon system, the evolutionary history of life on our planet, the origin of water, and several mass extinctions. On other planets in the solar system, asteroid impacts have resulted in various phenomena. The two distinctly different hemispheres on Mars are because of asteroid impacts some 3.9 billion years ago, and the unusual spin of Uranus was confirmed to be caused by a collision with a massive object twice the size of Earth. It's very rare for an asteroid the size of Apophis to pass so close to Earth, although smaller asteroids, in the range of 16 to 33 feet in size, have been observed passing by at similar distances. These type of asteroids are classed as near-Earth objects, or NEOs, and these objects and their orbits are constantly tracked by astronomers around the world. NASA uses Earth Impact Monitoring System to automatically track and scan asteroids that will probably hit us within the next 100 years. NEOs have become an increased interest since 1994, when big pieces of the Shoemaker-Levy 9 comet slammed into Jupiter after being torn up by its gravity. Scientists got to see it in real time, as Earth telescopes were recording it. This event highlighted the potential danger of NEOs. As of January 2019, 19,470 NEOs have been discovered. Only 107 of them are comets that are largely made up of ice and rock, while 19,363 of them are asteroids. These asteroids are classified into different categories based on their orbits and the danger they pose to Earth. So far, there are 4 orbit classifications. Amor class are types of asteroids whose orbits do not cross Earth's orbit around the Sun, thus posing no threat to us. The Apollo class of asteroids are Earth-crossing, whose orbits are greater than that of the Earth. Their perihelion, which is the nearest point to the Earth, is less than 1.017 astronomical units. 1 AU is roughly the distance between the Earth and the Sun, 150 million kilometers or 92.9 million miles. The 2013 Chelyabinsk meteor that exploded over the city of Chelyabinsk in the southern Urals region of Russia was an Apollo-class asteroid. As of December 2018, the number of known Apollo asteroids is 10,485, making the class the largest group of near-Earth objects. Aten's class of asteroids are Earth-crossing and are a dynamic group of asteroids whose orbits bring them into close proximity with Earth. Their orbits are smaller than the Earth's orbit around the Sun, or less than 1 AU. This makes them potentially hazardous objects, or PHOs. As of 2019, 1,490 Atens have been discovered, of which 12 are named. Apophis is an Aten-class asteroid that completes an orbit around the Sun in a bit less than 1 Earth year. After its close encounter with the Earth in 2029, the orbit of Apophis will be widened to become slightly larger than the width of Earth's orbit. At this point, it'll be reclassified from the Aten group to the Apollo group. Finally, there is the Atira class of asteroids, whose orbits are strictly inside the Earth's orbit and are no immediate threat as of now. However, their orbits can be altered because of the gravitational effects of the inner planets of our solar system like Mercury and Venus, which could make these Earth orbit-crossing asteroids in the future. Based on these classifications, scientists have also come up with scales to measure the impact hazards of asteroids. Scientists now believe that there is no danger of Apophis hitting us in April 2029. But space by its nature is unpredictable, and despite our best efforts, if tomorrow scientists discover an asteroid heading towards us, given our current technologies, there's really very little we can do. The only thing that will help us is time. The earlier we spot such objects, the more our chances of survival increases. Today, it's estimated that it would require us to have over a decade of planning to significantly alter the path of an asteroid's trajectory, or to minimize the effects of a potential impact. That's why searching for NEOs and tracking them have become such an important mission for space agencies around the world. This lack of human capability has also given rise to a new field of study known as asteroid impact avoidance. In recent years, many agencies around the globe have concentrated resources and funding towards future missions that aim to change an asteroid's trajectory. Since then, many scientists and engineers have proposed various ways to attempt this. Some have suggested we strap rocket engines to the rock that threatens us and push it away. Others have suggested that we use nuclear weapons to kick an asteroid from its orbit, or even shatter it into smaller bits. These ideas have led to ongoing missions such as the Double Asteroid Redirection Test, or DART, which is a collaboration between NASA and ESA to test the hypotheses of impacting a spacecraft into an asteroid to bring about a change in its trajectory. These days, scientists study asteroids' trajectory, size, shape, composition, and even their interior. All this research will provide humanity with the required knowledge to develop impact avoidance technology. Apophis flying so close to the surface of Earth in 2029 is such an incredible opportunity for science. The asteroid will be in range to be observed with both optical and radar telescopes. Radar observations could possibly provide surface details that are only a few feet in size. There are currently many missions being planned to make full use of this rare opportunity. That being said, there is still a small probability that Apophis has a chance of impacting Earth. In its close encounter with Earth, Apophis would pass through a gravitational keyhole, a small region no more than about a half a mile, 0.8 kilometers in diameter, that could set up a future impact exactly 7 years later in 2036. But the chances of that are said to be less than 1 in 100,000. This gives the asteroid an impact hazard of level 1 on the Torino scale. So despite its close approach, you'll not have to spend sleepless nights wondering whether it'll hit Earth or not. In August of 2013, scientists launched a project to map a portion of the southern sky which completed in 2019. It's called the Dark Energy Survey. An incredible 570 megapixel camera called the Dark Energy Camera grabbed data from over 300 million galaxies amounting to 50 million megabytes. Scientists have just begun to go over that data, and they found something that they didn't expect. Data created 32 images showing a blurry dot in the darkness of space, located about 2.5 billion miles away from Earth. It wasn't until it got close to the planet Uranus that astronomers were finally able to figure out what this strange object was. What scientists detected was a comet with a size 1,000 times above average. It was dubbed C2014 UN271, also known as Bernardinelli-Bernstein, after its discoverers. Given the amount of sunlight it reflects, astronomers speculate the object's diameter is somewhere in between 60 to 125 miles. That's an insanely big number. To compare, an asteroid that wiped dinosaurs out of existence is thought to have been just around 6 to 9 miles wide. But since Bernardinelli-Bernstein is still so far away, it's not clear whether the calculations are close to real measurements. Another fascinating fact about this comet is that the last time it entered our solar system was 3 million years ago. That's about the same time a well-known human ancestor, Lucy, lived. Given such a long orbital period, it seems the comet should have come from a very distant place. And it happens there's just such a place, believed to be home to trillions of comets. It's a place called Oort cloud, a spherically shaped region of space containing various remnants from the early ages of our solar system. The Oort cloud is located far beyond the dwarf planet Pluto and might stretch to 10,000 AU from our star. So scientists think Bernardinelli-Bernstein is the most remote comet we've successfully spotted on its way to us. Such an early discovery gives us plenty of time to study this comet and eventually explain its nature. So when will it get close to us? According to scientific estimates, the closest encounter with the Bernardinelli-Bernstein comet will come in 2031. So far, astronomers claim the comet imposes no threat, as it will fly by at a significant distance from us. The closest it will get is 11 astronomical units. That's about 10 times farther away from the Sun than the Earth. It won't even be visible in the sky with the naked eye. But since Comet's behavior is hardly predictable, we don't know what to expect. Unlike Bernardinelli Bernstein, certain celestial objects will get much closer to us, and a lot sooner. One of such space guests is a killer asteroid that will fly by within less than 0.07 AU. In just about a year, a binary asteroid named Didymos, accompanied by the smaller Didymoon, will make a near-Earth approach. The bigger asteroid is roughly 780 meters in diameter, while the smaller one is just about 160 meters. However, that's more than enough to make a crater that's 6 miles wide and demolish entire cities. Even space rocks that are 500 feet wide are capable of exploding with the energy equal to a nuclear bomb. A meteor, a tiny piece of an asteroid or a comet that exploded over Chelyabinsk, Russia, created a massive shockwave. As a result, tons of buildings were damaged and roughly 1,500 people were injured. And it was only about 65 feet wide. But data concerning asteroid impacts has become even more disturbing. NASA has recently conducted an experiment that proved we wouldn't be able to do anything about an asteroid heading straight towards us, even if we had 6 months warning. The simulation of the hypothetical scenario involved an asteroid at a distance of 35 million miles. Throughout each phase of the exercise that lasted a week, scientists received more and more data about the asteroid. They found out about the object's course, odds of hitting our planet, and its size, but they couldn't come up with a working solution to deflect it. Turns out we haven't yet invented spacecraft that could eliminate such a threat within 6 months. In fact, such a mission would take us 5 to 10 years. In the simulation, the asteroid would have landed on Eastern Europe. In fact, the only way to escape the big rock was to evacuate the impact area, and that's not helping us too much. But as we know, some things that don't work out in theory can show us good results in practice. So now, NASA plans to smash a spacecraft about the size of a refrigerator into the smaller Didymoon asteroid that was mentioned earlier. The mission is called Double Asteroid Redirection Test, or DART. The idea is to take this half-ton spacecraft and crash it into Didymoon around 4 miles per second. The launch will take place sometime between November the 24th, 2021 and February 15th, 2022. However, the collision should happen between September and October 2022. This is going to be the very first test using the kinetic impactor technique to alter an asteroid's trajectory and speed, and will be a kind of military training in terms of space. Now, Didymos doesn't threaten Earth yet, but NASA's database contains more than 2,000 potentially hazardous asteroids that can get as close to us as 0.05 astronomical units. Asteroids and comets are often hard to detect, even with the most advanced technology. But at times, people equipped with homemade telescopes make huge discoveries. Just 2 years ago, an amateur astronomer named Gennady Borisov stumbled across a celestial object with a peculiar trajectory. Turns out he found a comet, and not an ordinary one either. It was later discovered by scientists that 2I Borisov is a rogue comet. This is because this type of comet has no steady orbit and will freely float through space until affected by another celestial object. As astronomers continued to study 2I Borisov, they used NASA's Hubble Space Telescope and Atacama Large Millimeter Array, ALMA, to figure out the comet's extraordinary composition. It had an abundance of carbon monoxide they didn't expect to see, and knowing about this high concentration of carbon monoxide, scientists made assumptions about its origin. So far, astronomers have come to the conclusion it should have been created in a place overflowing with CO ice. Such an abundance of CO ice is only present in space regions with a temperature below -420 degrees Fahrenheit. There are 2 theories about how the comet formed. It could have been born around a red dwarf, a relatively small star with a low surface temperature. Otherwise, it could be a tiny fragment of a dwarf planet. This has become the first comet that entered our solar system from a place outside of our star's influence. But this is not the only thing that captured astronomers' attention. When approaching a star, a comet's particles start to melt and generate a fuzzy cloud around its nucleus. This cloud is called a coma. So what scientists noticed was a unique polarization in Borisov's dust grains. Now, polarization is the direction light waves ripple in space. The higher the polarization, the more focused the light is in a single direction. That's exactly what 2-1 Borisov's Comet demonstrated. In the scientific community, this was a big deal. Similar to the way our skin reacts to direct sunlight, the more a comet interacts with a star, the bigger the impact on its materials. Eventually, the polarization of the comet's coma gets reduced. But what we see with Borisov's comet is quite the opposite. This can only mean one thing. It is rarely or never bathed in a star's light, radiation, or winds. So it's one of the most untouched and well-preserved comets we've ever detected. This leads us to the conclusion that the comet contains unaltered information about the materials that formed it in the first place, which could have happened some thousands, millions, or even billions of years ago. And since astronomers believe the birthplace of 2I Borisov partially resembles our solar system, that comet can reveal valuable information about another solar system much like ours. Borisov's comet already traveled past our Sun in 2019. But this doesn't mean there aren't any other celestial objects about to visit us. We can only hope our telescopes will look in the right direction and at the right time, so that we can prepare ourselves once they show up. There are thousands of space rocks of all different sizes floating around in our inner solar system, and many of them are moving on a path towards us. These objects are called asteroids, and recently NASA has made some startling discoveries. You may have heard the news that an asteroid is hurtling towards the Earth, and you may have also heard that it's scheduled to wipe us out on November the 2nd, 2020. So, should we really be afraid of an asteroid impact? And if yes, what should we expect? Will humanity finally find a way to destroy huge, dangerous asteroids before one wipes us out? The asteroid we're talking about was discovered in 2018 by the Zwicky Transient Facility, which is an incredibly giant telescope in Palomar, California. NASA is calling it the 2018 VP1 asteroid, and it's about the size of a car. As asteroids are concerned, it's not huge, but the fact is, it's heading straight for us. If you take a look at Earth's orbit and the trajectory of 2018 VP1, you can see that it's coming awfully close to the planet. But there are some problems when it comes to knowing if an asteroid is going to smash into us or not. That's because it's hard to track the path of asteroids out there in space and predict where they're going to go. This is because some of them are too small and dull. In fact, even though 2018 VP1 was spotted a couple of years ago, NASA lost track of it and didn't know where it was. Even with advanced telescopes and dedicated observations, it's still very hard to understand where an asteroid is going to go. There are many things that can change the path of an asteroid. It can change path just from the heat of the sun, or another nearby wandering space debris, or even a planet can alter the course of an asteroid that could send it on a collision course with Earth. Asteroids hitting Earth really got people's attention after the recent Chelyabinsk meteor incident in 2013. This chunk of space rock was approximately 66 feet in diameter and entered the Earth's atmosphere over the southern Ural region of Russia at a speed of approximately 42,900 miles per hour. Although the asteroid disintegrated before hitting the surface of the Earth due to the intense heat produced by its entry, it still caused a fireball which was brighter than the sun and was visible up to 60 miles away. Some eyewitnesses also felt intense heat from the fireball. And then on August 22, 2020, it was claimed by NASA that an asteroid was headed towards Earth and would enter the atmosphere on November the 2nd, a day before the US presidential election. What immediately followed was shock headlines and social media posts sensationalizing the announcement, and because 2020 had already served up devastating bushfires, hurricanes, and a global pandemic, many people have become legitimately scared that even more devastation was headed our way. But it would seem for now that there is nothing to worry about, because asteroid 2018 VP1 is unlikely to hit Earth and should pose no threat to humanity. This asteroid was discovered by NASA back in 2018 while it was 280,000 miles away from Earth. It's estimated to come within 2,796.17 miles of Earth on November the 2nd. That's really close in space terms. There's a slight chance, about 1 in 240 or 0.41%, the asteroid will hit the Earth. However, the asteroid is so small that even if it enters our atmosphere, it's likely to disintegrate into a fireball and break up into a million pieces before reaching the surface. This recent scare caused by this close flyby shows it's the right time to analyze the effect asteroids have on our planet. Since the beginning of recorded history, there have been multiple records of asteroids impacting the Earth. Slightly over 65 million years ago, an asteroid now known as the Chicxulub meteor, which had the diameter of between 10 to 50 miles wide, slammed into the Gulf of Mexico and started an extinction event that wiped out nearly 75% of all life on Earth and is credited with the extinction of the dinosaurs. Elsewhere, mammoth craters of blasted out Earth have been discovered from the continental United States all the way to Russia, such as Barringar Crater in North America, Gossis Bluff in Australia, and Lake Bosumtwi in Africa. In reality, the chances of that happening within our lifetimes are fairly small. Our solar system has an entire region between the orbits of Mars and Jupiter known as the asteroid belt. This belt is estimated to contain between 1.1 and 1.9 million asteroids larger than half a mile in diameter and millions of smaller ones. Between 1988 and 2017, NASA counted over 700 fireballs created by different sizes of space rocks entering our atmosphere. In order to detect asteroids, NASA takes multiple pictures of the night sky and uses computer programs to scan for moving objects. These observations are made from multiple locations all over Earth, and as the planet rotates, several observations are made that keep track of the orbits of all asteroids and determine how close they are to Earth. The nearest asteroids are called NearEarth objects, or NEOs, meaning they orbit at roughly a third of the distance from the Sun. There are over 20,000 NEOs that are known and are currently being tracked. Based on the object's speed and brightness, scientists can map a trajectory to predict whether it will collide with Earth. If an NEO's orbit crosses the Earth's and the object is larger than 450 feet across, it's considered a potentially hazardous object, or PHOs. The impact energy of a 30-foot diameter asteroid is projected to be around 100 kilotons, but the larger the object, the deadlier the impact. A PHO with a diameter of around 500 foot, just a little larger than the Great Pyramid of Giza, has the potential of generating approximately 300 megatons of energy on impact. For reference, the number of megatons that was produced by the explosion of the most powerful nuclear weapon ever created and tested, the Tsar bomber, was only 50. This kind of asteroid strike could have the potential to cause millions of deaths and the destruction of entire cities. But the most worrisome thing is that asteroids don't always have to impact the surface of the Earth to cause damage and destruction. The Chelyabinsk meteor mentioned earlier dealt a lot of damage despite not hitting the ground. The blast created by the asteroid's airburst produced extensive ground damage over an irregular elliptical area around 60 miles wide and a few tens of miles long, with the secondary effects of the blast being the main cause of the considerable number of injuries. Russian authorities stated that 1,491 people needed medical attention in Chelyabinsk Oblast within the first few days, and over 7,200 buildings were damaged with collapsed roofs and shattered windows. That's why many nations around the world are scanning the sky for NEOs in an effort called Space Guard. The initial goal of the mission, to catalogue at least 90% of NEOs that are at least half a mile in diameter and could cause a global catastrophe, was met by 2011. Now the survey has been expanded to catalogue and track smaller objects which have the potential for large-scale, though not global, damage. For now, we are safe. But what if we spot a large asteroid coming towards us? What actions could we take? Our ability to prevent a devastating asteroid impact depends on how big the asteroid is and, most importantly, when we detect it. For example, a PHO on a path to collide with Earth, if detected 1 year out, is almost certainly going to impact us. The only thing to do would be to evacuate the impact zone. However, if it was detected 7 to 8 years out, then we would have a real chance to deflect the object. Currently, scientists have proposed various ways of doing this. The first method proposed is to detonate a nuclear device on the surface of the asteroid, or near it, so that the blast either breaks up the asteroid or pushes it onto a different trajectory. if the asteroid is far enough away, it'll only need to be pushed a few inches to bring enough change in its trajectory to miss Earth. Despite the risks of fracturing the asteroid and the unpredictability of debris after such explosions, this method of impact avoidance is still the most serious contender and has resulted in the creation of a conceptual Hypervelocity Asteroid Intercept Vehicle, or HAIV, which combines a kinetic impactor to create an initial crater for a follow-up subsurface nuclear detonation within that initial crater. The second, less drastic method to come out is the kinetic impact method, which literally uses a spacecraft as a battering ram to change the trajectory of the asteroid in question. This method has received major support from NASA in the form of the Double Asteroid Redirection Test, or DART mission, which is currently in its final stages of development and proposed to launch towards the target asteroid in the second half of 2021. The DART space probe's target is a PHO-sized asteroid called Dimorphos, located in the Didymos binary asteroid system. The idea is to impact the asteroid at a substantial velocity to initiate a trajectory change. The Didymos asteroid system is not in any Earth-crossing trajectory, so there is no possibility that the deflection experiment could create an impact hazard. If successful, this mission will be the first ever proof of concept towards asteroid impact avoidance. Other concepts include ideas such as the asteroid gravity tractor, where a spacecraft orbiting near an asteroid is theoretically enough to bring about a slight change in its trajectory due to the spacecraft's gravitational pull and the size and mass of the spacecraft. This system can, over time, redirect the asteroid, pulling it away from the Earth. Then there are proposed concepts such as focused solar energy and asteroid laser ablation, both using directed energy to cause jets of material heated by the solar energy or high-powered laser to fly off the surface of the asteroid, and that is essentially the equivalent of a jet engine pushing the asteroid off course. All these ideas are fundamentally strong, but need to be tested one by one to prove their effectiveness, and this will take time. So far, scientists and astronomers have not yet found any objects big enough or on course to threaten the Earth. But then again, we've not been searching for that long. There are still huge swathes of space to be surveyed and new technologies to be developed. It might be that a huge asteroid somewhere out there in the vastness of space is probably on its way towards us, and we just haven't found it yet. Our solar system began as a disk of dust and gas some 4.6 billion years ago. The first planets to form were the gas giants Neptune, Uranus, Saturn, and Jupiter. Jupiter took shape about the same time as the rest of the solar system, forming around 4.5 billion years ago, its strong gravity pulling in massive amounts of gas and dust from the disk before all the other planets formed. It was the first and the largest. Jupiter is mostly made up of hydrogen and helium, about 90% hydrogen and about 10% helium, almost the same composition as our Sun, which is about 70% hydrogen and 28% helium. Some astronomers call Jupiter a failed star. However, the gas giant only has a mass of 1,000th that of the Sun. Jupiter just isn't massive enough for gravity to trigger nuclear fusion. The beautiful whirling clouds and storms that you see in images, the layer resting on the surface known as the troposphere, are about 31 miles thick and are made up of ammonia, ammonium hydrosulfide, and water, which form the distinctive red and white bands. When you look at Jupiter, you probably think that it must have a solid surface. The fact is that Jupiter doesn't have a true surface. It's mostly swirling gases and liquids, and if you sent a spacecraft there, it would have nowhere to land. But just because the spacecraft wouldn't have a place to land doesn't mean it would fly right through Jupiter's atmosphere and come out unharmed through the other side. This is because extreme pressures and temperatures deep inside the planet would crush, melt, and vaporize any spacecraft trying to fly into the planet. But we've sent spacecraft to orbit and explore the planet. The $1 billion Juno probe, the farthest space probe ever to be powered by solar arrays, was launched towards Jupiter on August 5, 2011, and arrived in orbit around the planet on July 4, 2016. And what we've discovered and learned about Jupiter is incredible. The newest discovery using data collected from the Juno spacecraft found that the colourful stripes of swirling gas and dust you see in Jupiter's atmosphere were found to run 1,800 miles deep and hold so much gas that the mass is about 3 times that of the entire Earth. These belts of wind flow at speeds of 223 miles per hour and disrupt how mass is spread across the planet. It was also discovered that Jupiter's atmosphere is rotating differently, with zones and bands rotating at speeds that are different by up to 328 feet per second. Those bands on different colours you see are actually travelling in opposite directions. Lighter bands move in the direction of Jupiter's rotation, circling the planet faster than it spins, and the dark-coloured bands move slower in the opposite direction and take longer to move around the planet. So how does a giant ball of gas floating around in space stay together and form a planet? The Jovian magnetosphere is the cavity created in the solar wind by Jupiter's powerful magnetic field, ballooning 600,000 to 2 million miles and tapers into a tadpole-shaped tail extending more than 600 miles behind Jupiter. This magnetosphere is the largest and most powerful of any planetary magnetosphere in the solar system. Jupiter's magnetic field is generated by electrical currents in the planet's outer core, which is composed of liquid metallic hydrogen. This magnetic field was found to be almost 20,000 times as powerful as Earth and rotates, with the planet sweeping up particles that have an electric charge. The electromagnetic storms they generate are so strong that they can be heard by amateur radio operators on Earth beamed towards us by plasmas and magnetic field lines. These signals are sometimes even more powerful than radio signals from the Sun. This magnetic field traps swarms of charged particles and accelerates them to very high energies, and creates intense radiation that bombards the innermost of its 67 confirmed and named moons, and would destroy anything that got close. Speaking of Jupiter's moons, scientists have recently discovered an FM signal emanating from one of Jupiter's moons, Ganymede. If you want to see a video about this mysterious signal and Jupiter's giant moons, let us know in the comments. By now you may be wondering, does Jupiter have a solid inner core? Studies have found the planet's interior moves as a single body and behaves as if it were a rigid solid, despite its fluid nature. For now, we simply do not know if Jupiter has a solid core or not, but the Juno spacecraft should be able to help discover this, and what the mass and makeup of this solid core is if it exists. We do know that at Jupiter's core, whatever it's made of, the pressure is about 100,000 times the pressure on Earth. The Great Red Spot is one of the most iconic features of the planet. It's a massive storm the size of the Earth that's been raging since it was first sighted in 1831. Trapped between two jet streams, it's called an anticyclone that swirls about a center of high atmosphere pressure and rotates in the opposite direction that hurricanes do on Earth. It's the largest storm in the solar system, with wind measured around 400 miles per hour. Compare that to the fastest wind speed ever recorded on Earth of 231 miles per hour. One day this great red spot could end up disappearing completely, and scientists say that it's been shrinking since the 1800s, and may only last another 20 years. NASA's Juno spacecraft was able to snap incredible images of the planet as it passed at 5,600 miles above the giant red spot clouds in July 2017. One of the amazing things that was discovered is that deep in the atmosphere, pressure and temperature increase greatly and compress the hydrogen gas into a liquid. This gives Jupiter the largest ocean in the solar system, which is made of hydrogen instead of water. Juno also grabbed some spectacular images of the gas giant's poles, discovering another incredible wonder of the planet. At the North Pole of Jupiter, a huge persistent cyclone is visible, and encircled by smaller cyclones ranging in size from 2,500 to 2,900 miles. On Jupiter's South Pole, the same thing was discovered as Juno did a flyby, and using infrared cameras imaged a cyclone the size of the entire USA, with 5 other cyclones swirling around it in a geometric pattern, which also rotate counterclockwise. The NASA Galileo spacecraft was likely the first to discover these hotspots when it accidentally flew through one on its way to a planned demise to the surface of Jupiter. When the spacecraft was almost out of fuel, NASA deliberately sent the craft on a no-return plunge into Jupiter on September 21, 2003. This was done to protect the moon Europa, which some say has a subsurface ocean that could contain life. It's worth mentioning that we probably should be thankful for the planet Jupiter's size and the powerful magnetic field that it generates, because it's possible that Jupiter has saved the planet Earth from certain doom. People were laughing at the prospect of an asteroid or comet hitting the Earth in the late 80s and early 1990s, but then something happened that would quiet that laughter. The comet Shoemaker-Levy 9 was discovered by Carolyn and Gene Shoemaker and David Levy on March 18, 1993, using the Schmidt telescope at Mount Palomar. Scientists calculated the comet was originally 1 to 1.2 miles wide. However, tidal forces from Jupiter's powerful gravity had broken the comet into more than 20 pieces as it made its close approach to the planet sometime in 1992. But the biggest revelation was scientists saw that the fragments were going to smash into Jupiter, and luckily for NASA, its Galileo orbiter was still on its way to the gas giant. Many Earth-based telescopes and orbiting spacecraft such as the Hubble telescope all were focused on the incredible event that was about to happen. The fragments of the comet were lined up like a freight train and collided with Jupiter's atmosphere, unleashing the force of 300 million atomic bombs. The fragments created huge dark spots in the clouds that measured 1,200 to 1,900 miles and heated the gas giant's atmosphere to temperatures as hot as 53,000 to 71,000 degrees Fahrenheit. If a comet of this magnitude hit the planet Earth, the results would be devastating, with impacts sending dust and debris into the sky, which would cool the atmosphere and absorb sunlight and envelop the entire planet in darkness. This historic Jupiter comet impact is what led to planetary defense. But fear not, this type of collision was very rare, and scientists say probably only occur every few centuries. Or do they? On August 7th, an amateur astronomer was looking at Jupiter through his telescope when he captured an asteroid colliding with the atmosphere of Jupiter, creating a white flash visible in the clouds. Some scientists say these impacts are inevitable, with the amount of objects floating around in space and Jupiter's massive gravity tugging on anything that gets close to it. We could say that Jupiter's like Earth's big brother and likely protecting us from asteroid impacts. We've learned some new things about Jupiter and how its layers of atmosphere are made up, and we've also been able to image the planet in striking detail, piecing together images captured at the perfect moment for clarity called lucky imaging. The highest resolution image of Jupiter ever seen has been created in thermal infrared light. In the photos you can see the familiar banding. Bright regions are clear air, where heat from inside the planet can leak out, and darker regions are where the thick clouds block the heat from escaping. This proves that the interior of Jupiter is very hot, heat left over from its formation billions of years ago. When taking a look at Jupiter through the Hubble telescope, what you see is sunlight reflecting off the cloud tops. With these amazing images, we're learning more and more about Jupiter every day. And we're not done yet. In Earth's history, there have been 5 large-scale extinctions that completely changed the face of our planet. 98% of animal and plant species disappeared forever. 4 out of these 5 extinctions were caused by the impact of huge asteroids. It was these asteroids that wiped out the trilobites, giant mollusks, and then the dinosaurs. What are the odds that they will not be the cause of humankind's extinction? Where do asteroids come from? How big can an asteroid get? And what would happen if the largest asteroid we knew of struck the Earth? All these and more in today's video. Asteroids are the smallest heavenly bodies. They orbit around stars or planets. This is the scientific description, but one could put it more simply. Asteroids are essentially big rocks that fly through the vacuum of space on a given trajectory. Where do these big rocks, asteroids, come from in space? For billions of years, cosmic dust collected together into formations that gradually grew larger. Such objects are known as planetesimals, sort of building blocks for planets. The greater the mass of such an object, the greater its gravitational hold. As a planetesimal increases in size, it attracts even more cosmic dust and small meteorites, and by this, it grows even more quickly. If a planetesimal takes on enough mass, it can even turn into a fully fledged planet or a moon for another planet. Otherwise, it remains an ordinary asteroid. Cosmic dust accumulating is not the only way that asteroids can form. Sometimes they appear after big cosmic catastrophes, such as two planets colliding. One planet is quietly moving along on its orbit, but then it hits a large cosmic object and crumbles from the impact. The largest fragments of the destroyed planet become asteroids, while the smallest ones become meteorites. This is where the huge distinction in size lies. The diameter of a small asteroid does not exceed 328 feet. There are around 25 million objects with such a diameter just in our solar system. Asteroids that evolve from cosmic debris can grow to be quite huge. Meet Vesta. Vesta's diameter is approximately 326 miles, and its mass is 259 trillion tons. It's the largest asteroid in our solar system. A close second after Vesta is the asteroid Pallas. It has a diameter of 318 miles. Such giants are rare, however. Asteroids with a diameter over 186 miles can be counted on one's fingers. There are only 9 of them in our solar system. But are they really so dangerous? After all, the Earth is huge. What could an asteroid a half a mile across do? It would be like a mouse up against an elephant. The facts show differently, however. A small asteroid, just 328 feet across, is capable of the same destruction as a 50-megaton hydrogen bomb. It would leave a huge crater behind upon impact, and any nearby cities would be destroyed. A 650-foot asteroid could wipe out a small country, and a 1,600-foot asteroid could wipe Europe or America off the face of the Earth. These are not just theoretical calculations. Such disasters have already happened in Earth's history. 376 million years ago, Sweden's Lake Siljan was formed by an asteroid impact. The resulting crater was 32 miles across. You could fit a city the size of Russia's capital, Moscow, in such a hole. According to scientists, it was the Siljan meteorite impact that led to the Devonian extinction. 250 million years ago, in Antarctica's Wilkes Land, an asteroid 186 miles across struck the Earth and left a crater over 311 miles wide in the area and probably caused the massive Permian extinction. This was the largest ecological disaster in our planet's history. Never has such a thing happened before or since. Over 96% of oceanic species and 73% of land vertebrates were wiped out. After this extinction event, the Earth was emptied out. It took over 30 million years for the diversity of species to be restored. 199 million years ago, the Triassic-Jurassic extinction was caused by a tiny asteroid, only 2,460 feet across. Just think about that. In our solar system, there are over 2 million objects of similar size, and yet this one would cause an ecological catastrophe that destroyed 50% of species that inhabited the Earth. 65 million years ago, it was at this time that Tyrannosaurus, Velociraptors, Mosasaurus, and Pelorus utterly vanished from the face of the Earth. We know about the existence of these giant creatures only because people have extracted their fossilized skeletons. The cause of this tragedy was an asteroid with a diameter of around 6.2 miles. It fell on the Yucatan Peninsula and left behind a crater measuring 112 miles across and 12.4 miles deep. The force of this impact was equivalent to 100 teratons of TNT. That's 2 million times more powerful than the largest thermonuclear bomb. Were asteroids the cause of all large extinctions then? This cannot be 100% proven or refuted, but scientists are inclined to believe this is the case. The dinosaurs did not die because they fell into a crater. The hole in the Earth was actually a minor thing. The ecological catastrophe lay in other factors. The monstrous force of the impact awakened volcanoes and caused tsunamis over 328 feet tall. These gigantic waves swept deep into the mainland and drowned whole regions. A shockwave also spread over the face of the planet and sent tons of stone into the air. The result was enormous fires that destroyed millions of acres of forest. 15 trillion tons of soot went flying into the air, causing a sort of nuclear winter. The sun's light could not penetrate through these thick black clouds. The Earth was as dark during the day as at night. Photosynthesis in plants stopped. Temperatures on land fell by 50 degrees and in the oceans by 20 degrees. For many years, the temperature at the Earth's surface could not rise higher than 41 degrees. All the phytoplankton died out, and that formed the basis of the food chain for oceanic creatures. Fish, marines, reptiles, and the dinosaurs slowly died out. Some from cold and others from hunger. But just what are the chances that our planet will be struck again by an asteroid? You might be surprised, but they're actually quite high. Astronomers even use a special term, near-Earth asteroids. This is a group of celestial bodies whose orbits intersect the Earth's or come very close to it. That is how things look in theory, but it might be different for asteroids. Their orbits can change. Asteroids can collide with one another, and they're affected by the gravity of larger objects, either alone or all together. Periodically, asteroids that approach the Earth end up crashing into it, and this does not happen once every 100 million years, but much more often. Around once in every 10,000 years, humankind can expect a serious cosmic shock. Why don't ancient chronicles mention such catastrophes? Because ancient Egypt arose only 4,000 years ago, the Mesopotamian civilization only 6,000 years ago. We don't have any records older than that. Was it because people just didn't know how to write? Or might there have been developed civilizations that were wiped out? Now astronomers take the threat from space very seriously, and so do politicians. In the USA, Congress tasked NASA with identifying all space objects with a size larger than 450 feet and flying dangerously close to Earth. By 2012, scientists had tallied up 1,360 such asteroids. Astronomers have named the largest asteroids whose orbits come close to Earth. These are Eros, Icarus, Geographus, and Apollo. Eros has a diameter of 20.5 miles. Let's recall that dinosaurs were extinct from an asteroid just 6.2 miles across, i.e. 3 times smaller. If the asteroid Icarus, Geographus, or Apollo collided with Earth, they would not quite annihilate humankind, but they would cause terrible destruction to our planet and civilization as a whole. The global economy would crash. We would see famine and wars for resources. Humankind's cultural development would stop, and we could return to the ancient rules of survival of the strongest. People who survived an impact by one of these small asteroids would consider the movie Mad Max not fictional, but a documentary. But the most dangerous object in the solar system is the asteroid Apophis, which was discovered in 2005. In 2013, it already came quite close to Earth at a distance of 8.9 million miles. In 2023, it'll pass just 19,363 miles away, about 445 times closer. In 4 years, we'll be able to witness an incredible sight. As Apophis passes by the Earth, we'll be able to observe it not just with a telescope, but even with the naked eye. It'll be as bright as the stars in the Little Dipper. In 2036, Apophis will approach the Earth at a distance of fewer than 18,000 miles. Imagine that Apophis collided with our planet. The asteroid's diameter is not so great, just 1,066 feet across. However, that's already enough to wipe out a small European country. Scientists have proposed different values for the asteroid's destructive force. This is because no one knows what the asteroid's made up of, what angle Apophis would enter the atmosphere at, or where exactly it would strike. Astronomers have already determined particular high-risk areas: Kazakhstan, southeastern Russia, and the Caribbean. Scientists have even done some preliminary calculations. They suggest that Apophis's density is 187 pounds per square foot, comparable to an ordinary rock, and the speed at which it would enter the atmosphere is just 28,000 miles per hour. The asteroid would impact Earth with a force equivalent to 1,717 megatons. How bad's that? Let's compare. The atomic explosion at Hiroshima was 15 kilotons. The legendary Soviet weapon Tsar Bomber was 58 megatons, and the eruption of the volcano Krakatoa was 200 megatons. That means if this meteor fell on Earth, we'd end up with about 30 Tsar Bomber hydrogen bombs or 9 eruptions of Krakatoa. Now let's imagine that Vesta, the largest meteorite in the solar system, deviates from its orbit. Let's assume the same calculated values: a density of 187 pounds per square inch and an atmospheric entry speed of 28,000 miles per hour. If we now apply those values to an object with a diameter 326 miles across, the results are horrific. The force of the impact would equal 5 trillion megatons. This number is simply unimaginable. It'd be like the volcano Krakatoa erupting 5 billion times in a row. Even the most extreme director would never come up with something like that. You might try to calculate what size crater the asteroid would leave, but that would be pointless. It would be like playing agar.io at the moment when a big player swallows up a smaller one. Basically, such an impact would send our planet flying apart into hundreds of pieces. Perhaps some of these pieces, if they had the right shape, would become moons for other planets. Other fragments of our planet would become those same cosmic wanderers that are the asteroids. That's all we have for now. We hope that everything will be fine for our planet and that these asteroids will pass us by. We hope you've enjoyed this video, and thanks for watching.